So the next session for today is more practical on how to apply the algorithm to your data in the app. Again, as always in all the slides, I'm just putting the recap so that if you do go to different slide decks independently, you kind of have all the other links. So yes, we'll go over how to apply the algorithm and then how to download your classification data as well. So I've actually created, like I said, I don't think this will be too long. Oh, is that me? Is that me, or can everybody hear that?
I can hear that too, so I'm not sure what that is.
Yeah, me neither.
Yeah.
Oh, weird. Okay. Looks like it went away. All right.
Yeah, but sounds good now.
Okay. So I've actually, it's quite a short session actually, now that I look at the slides, but I wanted to just show you with screen records how you can do this in the app. So the first video that I'll show you is one we saw last week, which is how to import your data oh yes, Maria's just saying, should we get a photo before Rebecca leaves? I agree. Should we do that now? Maybe?
Yeah, sure.
I'm trying to figure out how. Oh, I think Fee, I don't know if Fee's back yet. Maybe we'll, I think she was in the line for coffee. So maybe I'll just pop. Oh, okay, Val's not back yet. All right, so when everyone is back, you turn on videos. So I'll just, I think we'll just have everybody kind of pop their video on when they're back so that we can pause and take the photo. All right, so yeah, as I was saying, what you would need to do in the app is, as we saw last week, import your data. So you can always do this with the example data that's provided in the tutorial. And, you know, obviously the process would be import your data, check the QC, download your QC report, and then classify. But today we're obviously just going to jump straight into the classification. All right, so I'm going to just narrate the video. So you can browse and upload your raw data. You just find the file on your local computer. You'll notice that it starts to populate the sort of QC section. And you'll get these tabs here. So for Becca, who wasn't here last week, you can check the raw data and just make sure you've got the right file by looking at example. This is actually the file name that you've imported. So you can cross-check that you're looking at the data you think you're supposed to be looking at. You can also click on check the run info and check the plate layout and just make sure everything looks as you expect. And then we would navigate to this classification tab, which looks, this is actually a zoomed in. I maybe should have shown what the actual page looks like, but this is the zoom in to where you actually select the algorithm. So as I mentioned in the previous session, you should be selecting the PNG algorithm because that was the algorithm trained for the data generated from the Luminex assay that was established at IMR. I've been working on this section below, which is not yet ready. It's in development, but I kind of envision that, you know, there might be an instance where you've done the QC for several plate data and you just want to classify. So I've been thinking through how you might be able to just upload the processed MFI RAU data directly and then classify. So at the moment, the expectation is, as I showed you before, that you go from importing your raw data, your plate layout, QC, classification. So kind of all of that process for one on a per plate basis. And then once we've selected this PNG algorithm, so it's actually the default one that's selected, so you actually don't even have to do anything. But yeah, if you were to select it, you can click on it again. Someone's dropped off. Right. And then in this video, this is kind of the follow on from that previous one. So we've imported the data, and now we've clicked on this classification tab, and you can see this sort of note that it's processing. So it's already doing the classification in the background. And then it populates here, and then you can scroll down. It's interactive. So then I just show you that you can sort by sample ID, you can sort by negative, positive, and you can also search interactively in the table. And so that was just to give you a sense of what you can do. So all of this is interactive. And, I always like to just search for positive and just see what pops up, because usually most of them are negative. Again, here you would be choosing PNG algorithm. You can check here. This is always showing you which algorithm you're applying to your data. So you want to make sure, that you're not using Melbourne algorithm. And if you were, it would actually show it to you here. So you can it's just a cross check that you're analyzing the data correctly. And then, yeah, that's the tip I've just given you here. You can see the algorithm choice as a cross check. And then finally, you can then click on the next tab for download data. And then there's two buttons here, and I've kind of done this on purpose because I want people to be very, to be thinking about which algorithm they're applying to their data all the time, because we don't want to be analyzing the data incorrectly with the wrong algorithm. And so you should be clicking on the PNG algorithm button. And it also populates here. So if this says Melbourne algorithm, then you need to go back and click the correct one. And then the downloaded CSV file will include the algorithm in the file name as well. So then you can also use that to cross-check. And the output data is just going to be a CSV of this table that you see here. So you'll have sample ID and the 3 classifiers. So if you remember from before, we have the prediction all, the prediction less than 3 months, and prediction greater than 3 months. So that was the classifier 1, 2, and 3. And that's actually it for this session, because it actually is that simple. But I did have some homework for you for next time. I would like you to try to import the raw data and explore the classification tab if you have time. I'd also like you to try downloading the classification data. And then next week, we will go into how to visualize your data in the app, and also some practical sessions on doing it together. So yeah, that's actually it for this, this session that shows you how to actually do it in the app. And I'll feedback, great. And I'll just, again, the resources and everything are here, and I'll just take questions. I can see that there is a question in the chat, and we lost Val at some stage, I just noticed. So from Shedrick, I understand that you use machines to classify algorithms, and machines can influence the classification algorithms. If it does this app have classifiers for mechanical errors? Does error occur during training of algorithms? So if I understand your question correctly, you're maybe asking what potential errors might be introduced into the training of the classification algorithm? So I think if I understand the question, can errors occur during training of the algorithms? And if by error you mean misclassification, then, yes, that can happen because the data is not black or white. The data does have, a spectrum of antibody levels for each antigen that can be, and every positive sample has a slightly different antibody profile. And so the algorithm does need to learn what that looks like in different instances. So that's where, your sensitivity and specificity, or the performance of your classifier, becomes important to understand, because it's, it's not 100%. I think it's around 93, 94% true positives, which means that we could be missing some positives. And that would be an error, if I'm understanding your question correctly. Does that actually answer your question, Shedrick?
Shazia.
Yeah.
Sorry, what? I'll just try and help him get across. We had to do a bit of translation in Pidgin.
I definitely can't answer if you told me in Pidgin.
So what I think Cedric is trying to ask is, if there's an error in the run and we get like a result that's an outlier, like say in PCR, maybe can I not use the PCR analogy? But if there's an error in a well in the run, like in the actual assay setup, what he's asking is that, is the app able to tell us if there's an outlier, like a result that's completely off? Or
so
does it make sense?
Yeah, I think I get the question. So I think I think the QC section of the app is where you would potentially see this.
Yeah.
So, and I think just by reading the question, I just want to clarify that the training of the algorithm that is applied to your data, that training already happened. So what we're actually applying to your data is the algorithm itself. It's not like it's training every time. So we've already trained it on the data set that I told you, and now we're just applying it to predict. And so it's doing, it's using all of the decision trees that it has built in to come up with which decision tree ensemble looks more like your data, and that's what it's kind of using to predict positivity or negativity. So, oh, should we try and do the, oh, sorry, Becca, should we try and do the photo before you pop off?
Sure, sorry.
Actually, I might need to get someone else to do it, because I don't know, can I do a screen grab if I'm recording? Maybe I'll just give it a go. Oh yeah, I think it will work. Oh yeah. All right, Val, Sarah.
I think Rebecca maybe dropped out as well.
Ask if they can see.
Well, still not here.
Oh no. All right. I think Palm team just needs to look at the computer.
That looks fun. Oh, do you want to move it? Yeah, which is
I hope that. All right, I'm just gonna do a trial. Ready? 1, 2, 3.
Wait.
No, it didn't come out well anyways. I'm not getting like the full screen. I don't know why.
I'm gonna take it as well.
Yes, please do, because
Okay,
I'm
cool.
struggling somehow. All right.
Wait, tell them to wait.
You pass it around this way.
And then because the phone's gonna get sorry.
Just saying that, like, yeah, closer.
It's too close.
There.
I see one hand.
Okay, just other way. Yeah.
There, that looks good.
Okay, look at Annie's hands.
Hurry up, my hand's aching.
Okay.
Ready?
Ready? All right, I think I got it as well. Thank you, Becca. Sorry, you're gonna be late to your other meeting.
So talk next time. Thanks so much.
Bye. Have a
Bye.
good weekend.
Bye. Bye all.
Bye, Rebecca, sorry.
Becca.
Bye.
Too many Rebeccas. So I lost my train of thought a little bit, but I think we were just discussing the algorithm question. And I think I was just trying to get across that, you know, the algorithm, it's not like it's training every time you run the app. It's just applying the algorithm to predict positivity in your data. Does that make sense? So I think if you want to be checking for outliers or errors in the actual data, so one thing would be, you know, the QC of, for example, bead counts for certain wells. If they look weird, then you might want to, you know, check those samples manually. And I think, you know, in the next session, when we talk about, in the next session, when we talk about how you can visualize the preliminary data. Oh, I can hear my echo. There we go. On the app, you know, that's where potentially an outlier would show up, because it shows you box plots of the MFI values for all your antigens. And no worries, Maria. And box plots for the relative antibody units. And so let's just say in that box plot, you have this outlier that is a lot higher, or that is 0 or something like that. It might come up there, but I don't know for sure that you will be able to pick that up. I think you also need to get in the habit of, with your process data, you know, possibly taking a look at that. You know, like when I showed you how to sort the values, you can sort by highest or lowest and see if anything looks a bit weird. And I guess if there is anything that you do come up, like some kind of plot or visualization that would be helpful to have in the app, you know, I think let's discuss that next week. And if there is something we can integrate, then we can. I just think it's a little bit hard to envision what that outlier might look like, and how you might notice it. So, you know, I think with PCR, Tama, your example from before, it's like if you have a sample that has a CT of 9, you know, like that's weird, right? And if it's lower than your highest first, you know, your highest standard curve dilution, then that looks weird. So, you know, you could do that as a check and look at your standard curve, MFI values, look at your unknown samples. But I think it's not as clear as it would be in PCR.
No, because you often like can have a responder for a particular antigen that might be higher than your highest point in your standard curve. And it doesn't mean that that's wrong. It's just the antibody levels. But I think if you, like you said, have done all your checks and balances for bead counts and your standard curve looks good, plus your negatives, then I don't know what else you could incorporate.
Yeah, and I guess in terms of the algorithm errors, you know, there is the possibility that you would have a false positive or a false negative. You know, like it's not perfect. So, you know, if there's a sample that you've looked at and it looks like it has really high antibody levels and it's not popping up, then maybe it is something to check manually and to have a discussion with everybody else. But yeah, does that sort of answer your question, Shedrick?
Sorry, we're just having some discussions to, you were gonna.
Initial one, not all the data come inside here. Also, maybe on the way to lose. Before all, also maybe comes a stage of putting data inside. Initially, time also when also creating labs, also factoring errors on the labs. Also anything.
I mean, when she was explaining,
Yeah.
It doesn't.
Yeah.
Yeah, it doesn't. do that.
Okay.
It only looks at the data, or it's fitting back to.
Okay.
Yeah, putting in different errors. I mean,
Like our classifier for errors.
no, that doesn't include it.
Okay. Okay.
I mean, if I understood what
Yeah.
Shazia explained about the algorithm, it didn't train for that.
Okay.
It only trains for, the antibody response, it only classified like up to 3 months prior to infection, and then 3 months to 6 months prior to infection. And then what's positive and what's negative, only that, and not if there was any errors in the.
But maybe can you give an example of like maybe a scenario what you.
I think Shedrick, maybe part of it is that it's kind of hard to define what an error would be in this kind of data. Like, I think like the PCR example, like there's definitely outliers where, or if you have one that's positive at 45, like you probably are like, well, we should probably rerun that one. Whereas with antibody data, like it's the magnitude of the antibody response varies from person to person. And so you can't say that because you have a low or a high value that it's an outlier, even though it might actually look like an outlier in your data because it's so much higher compared to the other people. But maybe that's just because that person had a really high antibody response to the infection, for example. And so, I think the QC that we've built in is probably the only way you could check for errors in the sense of like something going wrong with your run. But then if that all looks okay, then, whatever we're seeing should be real patterns in the antibody data. Does that make sense?
Identify as error. For in terms of like the values of MFI or MFA, it's just showing us the level of antibody in the body. This, something is a PCR, it's detecting parasite. Shazia,
Yes.
I think the answer to Cedric's question would be yes, because you've covered it in QC, where if the assay is a particular the analysis of, the results we're getting is invalid, it would be in the number of beats. So it's captured in the the layout where it either gives a red or blue. So if there's an error,
I think that's right. Or for example, if your blank samples were really, really high, then you would know that there's possibly cross-contamination on your plate, or something went wrong, and then you would just rerun that. So yeah, maybe it's thinking about like the algorithm is not what's going to tell you about the errors. It's actually the different metrics of the run that you're checking in the QC. Or, if your standard curve failed, like some of your dilution points didn't have any, fluorescent values, then you would rerun your entire plate.
I mean, in one run that we did recently with a cohort, they were longitudinal samples. And so we expected to see antibody levels decline over time. And at a quick look, it didn't do that. And so it was quite up and down in the wrong, what we just thought was the wrong way. So I assumed I'd pipetted the wrong samples into the wrong wells, and we ran it several times, and it turns out that it actually just was that antibody response. So sometimes it can be really unclear. But yeah, I think when it looks, you know, obviously like wrong, or not following the predicted trend, then that's when I would rerun things.
Yeah, so I think using the QC to just be confident that your run was robust, then, you know, anything in the antibody data is, you know, up for discussion. I think, like, okay, why does this person have such a high antibody level? Is it an outlier or is it real? And then you can maybe match it with the epi data. Oh, actually this person had a fever on the day that we sampled. So, you know, possibly there was an inflammatory response, you know, like, I don't know, I'm not an immunologist, but I feel like you could probably start to maybe try and figure out why. Or like Fee says, sometimes it's just different to what we would expect it. But if we're confident that the run went well and that it's, you know, it's past the QC checks, then we kind of report it as that. Any other questions from anybody else? Great, none from POM team, Moyame or Val and Sarah. Great. Moyame, none from, okay, great. So that covers the bulk of the Shiny app. So we've gone through, you know, the preparing your data, we've gone through the importing and the QC, and now the classification. So next week will be our final day, and we'll just be reviewing the whole process again, like a bit of like how today started, just a bit of a recap. So I think it would be really great if you could try to do this yourself for the next session. Give it a go, see how it is, and see if you have any questions. And we'll also go through the visualizations. We haven't done that yet. And then I think it would be great if you had a chance to look at it, so that if there is anything that you think might be useful to have integrated into that visualization section, which, you know, does show you some of the plots so that you can explore your data, like a quick look when you're in the app. Please come with that feedback. I'd be happy to try and integrate anything that you think would be useful. And we'll also have a practical session next week. So please do bring your laptop, or try and at least have one between two people. And we'll actually try and just give it a go together, so that I can, you know, be here virtually, but at